I want to find the pH of a 0.050 molar H2CO3 solution. So how am I going to do that? Well, I need to get a hydronium ion in order to find the pH. So I need to write a reaction. So I'm going to start with the H2CO3. And if it's in solution, I know that means I'm going to add water to it. It is at equilibrium, so I'm going to add an H2 water to give me the hydronium ion. And if I take away one H, I'm left with HCO3 minus AQ. Now, as you may have remembered, you don't break this apart when we studied it in Chem 1, but for the purposes of finding a pH, we do so that we can know that this is slightly ionized. So I need to look at initial concentrations. The only thing I was given was the H2CO3, which is 0.050. The water doesn't count, and then I had 0 and 0. I want to look at the change. I've got minus x, I've got plus x and plus x on the right. Then I need to find the equilibrium, which means I need to add straight down. So this is 0.050 minus x, and we just have x and x. So what are we going to do? Well, we're going to have an acid, so I have a K sub A. That equals to the products, right? But I need to know what is K sub A. So you get that from the little table in your book, which is 4.3 times 10 to the minus 7. I have x times x, which is x squared. I'm going to hope for the approximation because I don't want to have to use the quadratic formula. And then I'm going to cross multiply and take the square root. And when I do that, I get 1.46628 times 10 to the minus 4th. Now, was it a good approximation? Well, how do you know? Well, we take that number, and then we divide by what? We divide by the initial concentration, which was 0.050, and multiply the whole thing by 100. And what does that give us? Well, that gives me, hopefully it's correct, 0.29%, which is less than 5%, so the answer we got is going to work. But that's not what we want, right? That's the concentration of the hydronium ion. What I actually want to find is the pH. So in order to find the pH, we simply take the negative log of the hydronium ion, which is that long thing we just got, that 1.46628 times 10 to the minus 4th. And when I do that on the calculator, it gives me 3.83. Now remember, you want two significant figures after the decimal because we are dealing with logarithms.